Have you ever wondered how your phone sensors, volume knobs, or microcontrollers get exactly the voltage they need, not too high and not too low? That's all thanks to one of the simplest and most powerful circuits in electronics called the voltage divider. So for example, in this circuit, we have a 10 voltage power supply. So what if I only have a 10 voltage power source, but I only want 3 volts from it? Well, this is exactly what voltage dividers can do to help us. By dividing the voltage between the two resistors, you can adjust the resistance of each resistor to change the ratio of division across them, and therefore alter the voltage drop across each resistor. I will now demonstrate through this circuit. I have a 10 voltage power source here. The first resistor R1 is set to 1 ohm, and the resistor R2 is also set to 1 ohm. As both resistors are set to 1 ohm, the ratio is 1 to 1. Therefore, drop across each resistor is exactly half of the supplied voltage, meaning the voltage running through R1 is 5 volts and the voltage running through R2 is also 5 volts. To confirm this, I would set a voltmeter in parallel with the resistor 2. The voltmeter shows 5 volts, meaning it should also show 5 volts across resistor 1 due to 1 to 1 ratio. And here it is, the voltage across resistor 1 is also 5 volts. Now what if the two resistors have different values? What would be the value of the voltage across each resistor? For example, how do I work out the voltage across R2 if this is set to 8 ohms and R1 is set to 2 ohms? Well, there is a very simple equation, which goes like this. To find the voltage across any resistor, we take the total voltage, we multiply it with the resistor of concern, which is R2 in this case, and divide it by the total resistance. Substituting the numbers, we have Vin equal to 10 volts, which is the power source, R2 equal to 8 ohms, and the total resistance is 2 plus 8 equal to 10 ohms. And we end up with the voltage across resistor 2 equal to 8 volts. We can also apply a voltage divider rule to real-life experience. What if I had an LED light which could run on no more than 3 volts? What would be the resistance of R2 here if the R1 was equal to 2 ohms? So in order to find R2, we take R1 multiplied by Vout divided by Vin minus Vout. Substituting the values inside, we got R1 is equal to 2 ohms, Vout, which is our desired voltage, is equal to 3 volts, and Vin, which is our total voltage, is equal to 10 volts. After solving, in order for R2 to have 3 volts running across, R2 should be equal to 0.857 ohms. So here we are, we have covered the basics of the voltage divider rule. Next time you adjust a knob, read a sensor or power a circuit, remember, there's probably a voltage divider working quietly behind the scenes.